Students, today we are going to study in Science-2, chapter number 3, Chemical Reactions and Equations. Today we are going to see part 2 of this chapter. Heat is absorbed and given away in various processes and reactions. Accordingly, they are classified as endothermic or exothermic. Let's understand each one of them. In some reactions, for example, formation of ice from water or dissolution of sodium hydroxide in water or sodium metal placed in water. In such process of reaction, heat is given out in the surrounding. Such reactions are called as exothermic reaction. For example, in the process of dilution of concentrated sulfuric acid with water, very large amount of heat is liberated. As a result, water gets evaporated instantaneously if it is poured in to the concentrated sulfuric acid, which may cause an accident. To avoid this, required amount of water is taken in a glass container and small quantity of concentrated sulfuric acid at a time is added with stirring. Therefore, only a small amount of heat is liberated at a time. So we can define exothermic reaction wherein heat is given out or heat is liberated to the surrounding. Now, sudden reaction, for example, melting of ice, dissolution of potassium nitrate in water. Heat from outside is absorbed during some physical changes. Such changes or such process are called as endothermic process. So, what is exothermic process? A reaction that releases energy from the system in the form of heat. What is endothermic reaction? A reaction that the system absorbs energy from its surrounding in the form of heat. So we can understand from this schematic diagram exothermic and endothermic reaction. From this reaction examples, we have seen that some reactions are completed in short time, or that is occur rapidly, while some other require long time for completion, that is it occurs very slowly. It means that rate of different reaction is different. So now we shall see factors affecting the rate of chemical reaction. For example, during winter, long time is required for setting milk into curd, while at a higher temperature during summer, the rate of setting of milk increases and the curd is formed early. Now let us see the factors which decide the rate of chemical reaction. Nature of the reactant, size of the particles of reactants, concentration of the reactant, temperature of the reactant, and lastly, catalyst. Now we shall see one by one. First, let's consider nature of the reactants. On reaction, let's take the reaction of metals, aluminum, copper, and zinc with dilute hydrochloric acid. On reaction of aluminum, copper, and zinc with dilute hydrochloric acid, hydrogen gas is liberated and water-soluble salt of these metals are formed. From this reaction of aluminum, copper, and zinc, we observe that the reaction of aluminum metal takes place faster as compared to other two metals. That means the nature of the metal is responsible for this difference. So we can say that aluminum is more reactive than zinc, and zinc is more reactive than copper. So nature of the reactivity of reactants influences the rate of chemical reaction. Now second, we shall see size of the particles of the reactants. Take a piece of Take pieces and powder of shahbad tile in equal weights. Add 10 ml of dilute hydrochloric acid in each of the test tubes. We observe that effervescence of carbon dioxide is formed at a faster or a slower speed. You will see that the carbon dioxide effervescence is formed slowly with the pieces of shahbad tile while at a faster speed with the powder. So, from the above observation, it indicates that the rate of chemical reaction depends upon the size of the particle of the reactant taking part in the reaction. As the particle size decreases, the rate of reaction increases. As particle size decreases, the surface area per unit volume increases, which results in an increase in the frequency of collisions between reactant particles. Smaller the size of the reactant particle, higher is the rate of the reaction. Let us consider the reaction of dilute and concentrated hydrochloric acid with calcium carbonate powder. We observe that dilute HCl reacts slowly with calcium carbonate and thereby calcium carbonate disappears slowly and carbon dioxide gas liberates slowly. On the other hand, with reaction with concentrated hydrochloric acid, it takes place rapidly and calcium carbonate disappears fast. So, concentrated acid reacts faster than dilute acid. That is, the higher the concentration of a dissolved reactant, the faster the rate of reaction. The reason behind is, at a higher concentration there are more particles in the same amount of space. This means that the particles are more likely to collide and therefore more likely to react. So, the rate of a reaction is proportional to the concentration of reactants. While studying the decomposition reaction, we have carried out decomposition of lime water. In this activity, we have seen that the lime water does not turn milky before hitting the limestone because of the zero rate of reaction. From this, we can learn that the rate of a reaction increases on increasing the temperature. Increasing temperature means the particles move faster, particles collide more frequently with more energy, so reaction occurs faster. At a higher temperature, particles have more energy. This means they move faster and are more likely to collide with other particles. When the particles collide, they do so with more energy and so the number of successful collisions occurs. Now let's take the fifth factor, catalyst. On heating, potassium chlorate decomposes slowly. The rate of the above reaction neither increases by reducing the particle size nor by increasing the reaction temperature. It means potassium chlorate decomposes rapidly in the presence of manganese dioxide to liberate oxygen gas. But no chemical change takes place in manganese dioxide in this reaction. That means the substance in whose presence the rate of a chemical reaction changes without causing any chemical change to it, it is called a catalyst. Example, enzymes increase the number of collision, reduces the activation energy, the minimum energy needed for a reaction to occur. So, we can see the summary of the factors influencing the rate of reaction based on collision. Nature of the reactants, wherein the collision frequency is more in liquid phase. Temperature, it increases average kinetic energy of the particle, increasing the collision frequency of the constituent particles. Hence, the rate of the reaction increases with increasing in temperature. Concentration of the reactants, the more reactant particles that collide per unit time, the more often a reaction between them can occur. And lastly, the presence of a catalyst, because The catalase pathway has a lower activation energy. Because of this lower activation energy, the reaction rate of catalyzed reaction is faster than the reaction rate of uncatalyzed reaction at the same time, at the same temperature.